All right, so picking up where we left off. Good. All right, so we have changing angle of elevation. So this one here, we're going to look at a space shuttle taking off. All right, so here's a picture that goes with this one. Here's our camera. Okay, this is our camera. And then here's a space shuttle. See, it's taking off. See that? It's pretty slick looking, isn't it? All right, that's not quite the Falcon X Elon Musk version, but you know, it'll work. All right, so there's a shuttle taking off. We are 2,000 feet away from the launch point. Okay, here's the launch point. So it just made us a right triangle, correct? All right, so we want to find the rate of change in the angle of elevation of the camera during the space shuttle launch at 10 seconds after liftoff. A lot going on there. All right, so there's the camera. We are looking for the rate of change of that angle right there, that angle theta. So basically, I'm sitting here with the camera, and that space shuttle is taking off. At what rate am I lifting my camera, essentially? At what rate am I pivoting that and changing that angle? Does that make sense? All right, so we also know that our launch speed, in this case, is s here. All right, so it's the speed of the space shuttle. Think about space shuttle taking off. What does it do? It sit there and kind of rumbles. It's like, oh, and then it gets faster as it gets higher, right? So our speed is going to be represented by s equals 50t squared. Okay, so that's our launch speed. So right now, everything here has been supplied. This is the entire question now. Does that make sense? All right, so we got to figure out what's given. We got to figure out what we have to find, and we have to figure out an equation that relates both of these things. So if we look at this, we do have a given rate, don't we? Yeah, we have a given rate, and our given rate is the 50t squared. But that's just an equation of what the speed is, right? Or an equation for the position. So how do we find a speed of an equation? Differentiate it, right? Right? So let's find ds or s prime. Let's make it s prime. So s prime is going to be what? 100t. There we go. So we just turned that position function into a rate. So we know that. So our given rate, or in this case, our ds dt, is going to be 100t. That's the velocity of our rocket here. Okay. We know we want to find change in the angle of elevation. So that's our d theta dt. And we want to find it when this is 10 seconds. When t is 10. Okay. Now, we're going to have a couple different things. So we're worried about the 10 seconds, right? So let's plug this in. Let's see what the speed is at 10 seconds. So 100 times 10 is going to be what? Sorry, I got to plug it in here. I looked at the wrong one. All right, so I want to figure this out. Of 100 times 5 from times 50, which is going to be 5,000. So at 10 seconds, we're going to be 5,000 feet off the ground. Okay, that's what I was worried about. So 10 seconds, t is 10, and s is 5,000. Just a lot of things going on in these problems. Okay, so now we have to find an equation that relates these things, right? We got to find a way to relate theta and s. Now looking at this, do you see anything that could relate those two? A trig function? A right triangle and an angle, don't we? So yeah, tangent. Good. The tangent of theta is equal to opposite over adjacent. Opposite is s. Adjacent is 2000. So there, that gave us something that related those two things. All right, we had to be able to relate d theta and dt, and we had to be able to relate s to it. So there we go. All right, now we want to find the speed that that angle changes, though, right? So let's take that equation we just found, and let's find the derivative on both sides of it. Tangent theta equals s over 2000, and find ddt of both sides. All right, do you remember what the derivative of the tangent is? Anybody? Secant squared. Secant squared of theta. All right, and then that would be d theta dt. On the other side, find d dt. What the s goes away. Basically left 1 over 2000. All right, the whole constant's multiple thing, and that would be with respect to s though, ds dt. All right, so we're looking for d theta dt. So therefore, we're going to have to divide both sides by secant squared, right? With me? Divide both sides by secant squared. Then that's going to be a fraction over a fraction. That gets a little bit ugly. What's the same as dividing by secant squared? Multiplying by cosine squared, right? Yes. Remember? Yeah. Secant and cosine. Flip them. All right? So let's turn this now into the theta dt be cosecant squared of theta. All right? And then we'd have that 1 over 2000. All right, still with me? Start plugging some stuff in now. Okay? Because that's still ds dt. All right, so first off, we are going to have to replace this guy with our theta. We're going to have this guy and ds dt. Okay? So ds dt is 100t from up here. Okay? So I'm going to have 100t over 2000. All right, with that, there's just those two places. I just went ahead and multiplied those two. All right, now I also have to find the cosine squared of theta. Well, if I look up here at my right triangle, cosine is adjacent over hypotenuse, correct? Here's my adjacent. Here's my hypotenuse. I don't know that. So it's going to be 2000 over something squared. So we'll figure this out real quick. This would be Pythagorean theorem, wouldn't it? So we'd have essentially s squared plus 2000 squared square root of that. Okay? Square root of s squared plus 2000 squared. Looks really ugly, doesn't it? Now the last thing we need, that's everything plugged in we can here. Now this will be our equation. We could simplify it a little bit, but let's take it. Let's plug these numbers in and get a real number. All right, so I'm going to have t is 10 and s is 500. I'm going to plug both those into what we just did there. What's that? 5,000, yeah. All right, so d theta dt, which is right here, I'm going to plug in across the board. I have 2,000 times 100 times 10 over 5,000 squared plus 2,000 squared. All I did was I distributed this through here. Okay, distributed and divided. All right, so I plug those values in, and I end up with 2 over 29. Okay, and what that would be is 2 over 29 is radians per second that angle is changing on my camera at 10 seconds. Kind of cool. A lot of work, isn't it? It's a lot to process. I will very much limit these types of things, you know. This phone's ringing.
Sound like a fax machine.
It's not my phone, is it? Alright.
Sounds more like you're dialing somebody.
Alright, last one. Ready for this one? Not doing it tomorrow. Alright, so velocity of a piston. This is kind of cool. It's not 2. In a certain engine, a 7-inch connecting rod is fastened to a crank with a radius of 3 inches. The crankshaft rotates counterclockwise at a constant rate of 200 revolutions per minute. Find the velocity of the piston where theta equals pi over 3. Alright, so first off, let's think of how a piston works. Okay? So, here's the walls of the block. Alright? Here's the piston. Something like that. Okay, there's the head of the piston. Then we have connecting rod here. Okay? Then we have a crankshaft here. So there's little tabs on there, so I'm just going to draw it a little bigger. It's going to look something like this. Okay? This thing is rotating in a circle. So when it rotates in a circle, what happens to that bottom? It goes like this. See what I mean? So the piston's going up and down. The lever underneath is going back and forth. And it all has to do with this thing cranking around in the circle. You with me? You guys kind of have a picture of what a piston looks like when it's going up and down. It's coming up and down. Crankshaft is spinning like this. There's little just tabs on it. And when it spins this way, it brings that lever underneath, goes straight up and down, making the piston go up. When it starts to come back down, it kind of goes like this. You can see my arm. That's kind of the motion it makes. All right, that's the closest thing I can do to it.
You're ready for the
Yeah. All right. So, if we think about this, though, all right, we have a 3-inch radius. We also have a 7-inch rod. Okay. So I have right here. I have a triangle, though, don't I? That's changing. It's not a right triangle, though. That's the problem. This is actually the triangle that we have. I just kind of laid it down. Okay, it's not a right triangle. Right here is the angle of this changing right here. Okay, this has a radius of 3. This is 7, and we don't know this side. Okay, that would be the vertical motion up and down. So we have that. So let's think a little bit. That's all we're given stuff. So what do we have? We know that it's spinning at revolutions per minute, right? Crankshaft is spinning at 200 revolutions per minute. So therefore, our theta is changing. That's our d theta over dt. We know that guy. All right, done. All right, and we know it's 200 revolutions per minute. Now, I see that we're going to be looking at radian measure here with pi over 3. So let's turn this into radians. Every rotation is how many radians? 2 pi, right? 2 pi. So 1 revolution is 2 pi radians. So I'm going to multiply this guy by 2 pi. So 2 pi times 200. So now that's going to be 400 pi, and that would be radians per minute. Okay? what we want to find is we want to find dx, which is this change in vertical motion up and down by that piston, to dx dt, and we want to find it when theta is pi over 3. Okay, those two things were said. Now, we have to find an equation that relates to this, right? That's not supplied to us. So we have to do a little thinking. This is not a right triangle, right? We agreed on that. It's not a right triangle. So, what type of thing can I use to relate the side and the angle of a triangle that's not right? You remember? We butchered this on a test in pre-calc. This is the test I gave back to you to make changes. Maybe the law of cosines. Remember the law of cosines? What? So law of cosines, in this case, let's use this version. So b squared equals a squared plus c squared minus 2ac cosine of theta. Remember that one?
I only know, I know it from physics. I don't remember it in here.
We did it. Uh-huh. This is when I gave you a triangle with like a side and a angle, and you had to figure out all three angles and all three sides. This is on a test. It was the very first
I
page.
cannot do that.
You remember that? You had to figure out little a, little b, big B.
There was not a Google solution. Just trust me, I tried.
All right, so that's what we're going to use because it can relate these items for us. In our case, we have 7 squared equals 3 squared plus x squared minus 2 times 3 times x cosine of theta. Okay, so what I just gave you there, I'm going to simplify it just a little bit. That'll be our equation. What's that? Negative. Minus 2 times 3 times x times cosine of theta. All right, so let's just simplify that just a little bit before we go on. We're looking at, what would it be, 49 equals 9 plus x squared minus 6x cosine theta. Is that all right? All I did was just simplify it a little bit. Now, that's our equation. So let's take that equation and let's do some implicit differentiation. Okay, so 49 equals 9 plus x squared minus 6x cosine of theta. All right, I'm going to find ddx, or ddt for both sides. dt. So this side's 0. 9's gone. I'm going to have 2x. I differentiated an x, so that would be dx dt. All right, then the next one, I'm going to have a little bit of chain rule going on. So I'm looking at, thank you, would be negative 6, negative x sine theta of d theta dt plus cosine of theta dx dt. Right, all I did was just apply the chain rule to the negative 6x cosine of theta. That's all. Yeah. All right, I'm gonna go ahead and distribute now. I got to work to get dx dt on a side by itself. So let's go ahead. 2x dx dt plus 6x sine theta d theta dt minus 6 cosine of theta dx dt. All right, I want to get the dx dt's on the side by itself. So I'm going to take this guy and this guy. What I'm going to do, I'm going to take them over to the other side and factor it out. So that's going to give me 6 cosine of theta minus 2x dx dt. And then that's going to be equal to just what's left over, 6x sine of theta. And that's d theta dt. All right? Still with me? No? You just copying now?
I've been at that point for a while now.
All right, then we just have to divide both sides by this over here. It's going to leave me with dx dt is 6x sine of theta over 6 cosine theta minus 2x, and the whole thing is d theta dt. All right, now we got to stop and do a little bit of some numbers. This is the time we start plugging, right? But we really don't have a lot right now. We have dx dt when theta is pi over 3, so that's what we're looking for. So what we need to do really is we got to go back through and find out then at that time what our values are, what our values of x are. We don't have that right now, do we? So we got to find out at pi over 3 what is my x value. I can plug in and find that one, then plug that in over here on the left. All right, so I'm going to come down here to the side, and I'm going to use my original equation again. That 49 equals 9 plus x squared minus 6x, and I gotta find the cosine of pi over 3. What's cosine of pi over 3 on the unit circle? Anybody remember that one? Long time ago, I know. If you put in your calculator, cosine of pi over 3, what do you think you're going to get?
Go with 30 degrees.
It's going to be a number. I gave you the angle, remember?
How was that a number?
Did you say 1/2?
Yeah.
Yeah, great answer. The cosine of pi over 3 is 1/2. That's a great answer. I knew that's what you were thinking. All right, so.
How did you get a number out of that? Oh well, doesn't matter. Doesn't matter. I got a calculator.
All right, so that leaves me here. Okay. Cosine pi over 3. You go 60 degrees up. You have.
So it's 60.
Pi over 3 is 60 degrees, yes. But we're talking radians, not degrees.
So 1/2 is equal to
1/2 is the value of the cosine function at 60 degrees. Put cosine of 60 in your calculator once.
That's what I said. I don't need to know how. I've got a calculator.
Okay. If you put cosine of 60 or cosine of pi over 3 in your calculator, you're going to get 1/2.
Okay.
Believe me? Okay. Better believe me. All right. So simplify a little bit. Let's just solve this for 0. So I'm going to have x squared minus 3x. Bring that 49 over. Is negative 40. So I'm solving for x. How can I solve this guy now? One word starts with an F, and it's not that one. What is it?
Fun.
Fun. I like it. This is fun. Rhymes with tractor. Fractor has an extra R, but yes, factor would be a great idea. What's that guy factored to? You know, and it's not prime. What's two numbers that multiply?
You do your thing. I'll figure it out.
What's two numbers that multiply to get 40? Add to get negative 3. 8 and 5. There we go. There'll be a negative 8 and positive 5 since the 3 is negative, right? So I set those both equal to 0. I'm going to get x equals 8 and x equals negative 5. Can that distance of that connecting rod to the piston ever be negative? No, it still exists. We can't have a negative. So this is our only valid answer. So now we're feeling good. Now we can finally find what dx dt is when theta is equal to pi over 3. Okay? So I know that x is 8 when theta is pi over 3. I took my related rates together, combine them to find what's going to be going on here. So I know then that dx dt is equal to, we're just plug and chug time now. Okay, so when we plug and chug, we're going to get that 6x, x is 8, and then the sine of theta, I marked it over here, sine of theta, we found the cosine of theta. Sine of pi over 3 is going to actually be root 3 over 2, if you put that in the calculator. Use the unit circle. Alright, so I have 6 times 8 is root 3 over 2 over 6 times the cosine of theta, which we've just found was 1/2, minus 2 times x, so we have 2 times x, which is 2 times 8, negative 16. And then the whole thing is times the theta dt. The theta dt is 400 pi. Alright, start simplifying a little bit on top. I'm going to get 9600 pi over root 3 over negative 13. And at the end of the day, I'm going to get negative 4,118 inches per minute. So after all that, I get a nice satisfying answer. That at pi over 3, on the rotation on that crankshaft, that speed of that piston is 4,018 inches per minute. Why is it negative though? Any ideas? Perfect, because it's counterclockwise. All right, because that crankshaft is turning counterclockwise, it goes against. What's that? Okay, so right here, pi over 3, based on the way our location is. It's this, right?
Okay.
Pi over 3 would be right here. So at that minute, with this guy rotating like this, it's going down.
Okay.
Pi over 3 is going towards 0. Therefore, at that moment in time, it's coming. The piston will be coming down in the block, making that negative. Questions? Wasn't that one just fun?